Let's build a simple Markov chain model in Python to help you better understand how it works. My favorite way to think of a Markov model is as a simulation of a system, whether it be fictional or real world, that moves through a finite set of states with every time step. And each state is chosen solely based on the current one and a fixed set of transition probabilities. And if you're confused by what I mean, definitely check out the precursor video, which explains the concept of Markov chains in depth. But now let's get coding. Today we're implementing the simplest possible Markov chain for a weather example. The world we are simulating only has two possible situations or states. On any given day, it can only be sunny or rainy. The whole Markov idea is that the probability of tomorrow's weather depends only on today's weather and not the entire history of previous days. Again, if this is confusing, go check out part 1. With that said, let's open up our notebook. Today I'm using Jupyter Notebook, but you can also use Visual Studio's Code or any other platform you like. This first line is telling Python that we want to use functions from the random module. This model implements a magical random number generator, which really means it produces numbers that behave like random numbers but are actually generated like an algorithm. Now this next line creates a Python list with 2 elements, and this list is called your state space. By writing this down explicitly, you are deciding that the only possible states the model can be in is these 2 states. This next block of code creates a dictionary called transition probs, and it houses, you guessed it, our transition probabilities. A dictionary in Python is like a lookup table. Each key is something you know, and each value is something you want to retrieve using that key. Here the keys are sunny and rainy, and the values are lists of 2 numbers. These probabilities describe the likelihood that the system moves from the current state to the next possible state. Before the key sunny, the list of 0.8 and 0.2 means that if the current state is sunny, the probability that tomorrow is sunny is 80%, and the probability that tomorrow is rainy is 20%. And it's the same logic for rainy. If today is rainy, there's a 40% chance tomorrow will be sunny, and a 60% chance it will continue to rain. Notice that in each list, the probabilities add up to 1, which reflects the fact that the state cannot be anything else besides sunny and rainy. Next, we're calling a function called nextState, and here we're telling the model, given that I am in this state right now, figure out which next state I should be in according to the Markov rules. We take the current state as a parameter, and the model looks up the correct list of transition probabilities for that state. The random choices line then uses those probabilities as weights to randomly pick one element from the sunny rainy list. So states with a higher assigned probability are more likely to be chosen, but there's still some randomness. The function finally returns this single state label, so each call to next state corresponds to one Markov step. And we're staying true to the rule that the next outcome is generated purely from the current state. Now it's time to actually simulate the scenario. After initializing some variables like the length of the simulation, which is 10, and the number of steps, we use a for loop. Inside the loop, the variable t goes through the numbers 1 through 10, so each pass represents a new day in the simulation. On each day, the code calls the next state function we defined before, which uses the Markov transition probabilities and randomness to decide what the weather will be tomorrow given today. The result of that function replaces the old value of the current variable, so current is always the most recent state of the system. Then the loop prints which day it is and which state the model is currently in, building up a day-by-day record. Finally, we are visualizing this using a bar plot with matplotlib. And it looks like that if we're starting on a sunny day, the majority of the next 10 days will also be sunny. And that is the simplest of Markov models coded in Python for you right in front of your eyes. You can check out the full code here, so don't forget to save this video for the next time you're working with Markov models and follow for more.